So we're talking about probability of an event and perhaps odds. Does it say probability the whole time? It does. Okay, so it is just probability then. I won't even confuse you with the odds. The probability of an event occurring is, this is number 13, yep, is the good choice or the favorable choice over the total possible choices. So if I say, what's the probability of it being sunny today? Sunny would be the good choice. There's a 90% chance of sun today. That would mean, right, good would be the amount of sun I could see over the total number of hours in the day. So it's supposed to be sunny how many other hours over, does that make sense?
Yeah.
Good is what you want to have happen. If we look at this in terms of geometry, you're just going to see a lot of the area stuff come back into it. So you want to find the area of something or the length of something. For example, 13. We'll do the A first. The point is on xz. So in this case, what's considered favorable? X to z, right? That's considered favorable. Because I want it, it's like throwing darts at this thing or whatever, and I want it to land on xz, on that segment xz. So what is the length of the segment xz?
8.
What's the length of the whole thing? 8 over 10.
Reduce that.
You need to. Yep. Now a lot of percent is written in, or a lot of probability is written in percent. So if you were to write it as a percent, that would be great too, but it's not a requirement. 4/5 is just fine.
So we wouldn't get docked points.
No. Nope. Okay, but it does get a little bit more confusing from time to time. For example, it says, and I'm not going to do it with you now, but it says that the point is not on XY. So what would be the favorable then?
W, X, and then Y, Z.
Yeah. So you just kind of want to be careful about what it's asking. All right? But good over total. Does that make sense for that section?
Even if it doesn't include the 20, it's still over total, so like it would be 5 times.
B would be what?
B would be 5 over 10.
Yeah, the total's always the same.
Okay.
Yeah, yep. All right, moving on to the next type. We're going to skip 14 for now and look at 15. It's what the bell ringer had. I mean, you had both of these types on there. With this pie chart, the question might be, what is the total? Did you guys come up with that on your bell ringer?
No.
Okay. Does anybody have a guess for it now? Yes. 360. The total is 360 degrees within a circle. So the total, in this case, is 360. And then I know you can't see at all. This is a really bad example. But I think it has a B, a Y, and a G. Can you read that?
Yeah.
So this is blue, this is yellow, this is green, I think.
Which one's the B? Is it the one that looks
This
like
is blue, this is yellow, this is green, this is red, and thank you, orange. All right, let's do number D, letter D, 15D, number D. Okay, letter D, letter D.
Number D.
I know, I said it wrong. The pointer landing on blue or yellow. So what is the blue and yellow?
90 plus 60.
So do you see how you add them together? Just put them together. So it's a total of what? 90 plus 60 is
150.
150 over 360, and then you need to reduce that. So 15 over 360, or 15 over 36, does that go down any further?
3.
Yeah, good call. So 5 over, and you can figure out that percentage if you wanted to, but 5/12 is perfectly acceptable. If you're going to do decimal, do percent. Otherwise, leave it as a fraction. All right, and then the last, are you good? Are you agreeing with me? This is not too hard? We're not feeling stressed yet? Okay, good. And then the last piece of this is just putting in area formulas. So now this is a much better idea of if you were to throw darts at this picture, what is the chance that you will land inside the square or the triangle, or this one says not inside the square? Ooh, this is a really loaded question. How would I do this one?
You would add them all up and then subtract them from the biggest area.
Perfect. Yep. Now, it is possible that somebody could be really mean to you and have you do a 1/2 apothem, 1/2 ANS, right? 1/2 number of sides, kind of sides. This one is not that, I mean, you don't have that issue here, but just know that it's possible this could, where is it? Here, could happen. If you already had that information, it is fair game.
If there is a regular polygon beside it.
Yes, if there is a regular polygon inside of it. Do you need me to do one of these, do you think? Or do you understand? Okay. I'm going to